My project is called Displeased Boxes, and the basic idea was to create a rigid body simulation in which the user can launch rigid bodies at other rigid bodies to try and destroy a set of targets in a game akin to Angry Birds or Crush the Castle. Here are the four levels I made. Green objects are the static bodies, gray ones are the rigid bodies, and the yellow ones are the targets. The main collision detection algorithm takes advantage of the separating axis theorem, and this states that if two objects can have a line drawn between them, then those two objects cannot be colliding. And we test for this by taking each normal, projecting the points of both objects onto said normal, and if there are no overlaps between the two objects based off their points, then that means we could draw a line between the two objects perpendicular to this normal, and we test all the normals. But if all the normals they don't have a possible line, then that means there's a collision, and so then we need a collision response. And so um, the hard part is to, like this, you just plug the numbers in these equations, but the hard part would be to determine, since all the normals register a collision, you have to filter through, you want the overlap, the normal with the overlap that's the smallest, so that the objects, um, the impulses looks intuitive, and the objects, the separating movement between the two objects is the smallest distance possible. So you just have to filter through all the uh, outputs from each of the normal tests. Um, there were some limitations. There is no continuous collision detection implemented in this, which wasn't a problem, but it could be if this is expanded upon. So if the frame rate were get too low, or if objects were moving too quickly, you could see where that would be a problem. Friction, the implementation I have is imperfect in the sense that collisions are a binary. They don't take advantage. They don't think about the surface area between um, two objects colliding, which is pretty important for friction to determine how much friction to add. It's only based off of points and whether there is it's a binary. There is a collision or there's not. And then there is more efficient collision detection algorithms that are out there, and there are some optimizations that could be done for the separating axis theorem based ones. Like with a square, you only need to test half the normals. The other half's redundant because they're essentially the same. I didn't do that, but one could and would make it faster. And then here's all of the levels. Here's the showcase.